We're going to wrap up our work with the normal distribution just by looking at a few problems from your textbook so that you're used to seeing problems worded a different way. Here's a question straight from your text. A cereal manufacturer has a machine that fills the boxes. Boxes are labeled 16 ounces, so the company wants to have that much cereal in each box, but since no packaging process is perfect, there will be minor variations. If the machine is set at exactly 16 ounces and the normal model applies, or at least the distribution is roughly symmetric, then about half of the boxes will be underweight, making consumers unhappy and exposing the company to bad publicity and possible lawsuits. To prevent underweight boxes, the manufacturer has to set the mean a little higher than 16 ounces. Based on their experience with machine packaging, the company believes that the amount of cereal in the boxes fits a normal model with a standard deviation of 0.2 ounces. The manufacturer decides to set the machine to put an average of 16.3 ounces in each box. Let's use that model to answer a series of questions about these cereal boxes. So our first question is, what fraction of the boxes will be underweight? So to answer this, I am going to go to my normal model because it specifically tells me that we can assume that a normal model applies, okay? So I'm going to do a sketch. I'm going to put the mean, 1, 2, 3 standard deviations, 1, 2, 3, capital N. The mean is 16.3 and a standard deviation of 0.2. So I'm going to label my x-axis, and we want to know what fraction of boxes will be underweight. So it's really asking what's the probability that x, an individual box, is less than 16 ounces, because they advertise that the box contains 16 ounces. So that's right here, this 16. And underweight would be the area to the left. So I could standardize and use table A, or since I'm looking for the area, I can use the calculator function. Normal CDF, lower would be -9999, upper 16, mu 16.3, sigma 0.2. Type that in, see what you get. I get 0.067. So my conclusion is approximately 6.7% of the boxes will be underweight or less than 16 ounces. Okay, same scenario, but now it says the company's lawyers say that 6.7% is too high. They insist that no more than 4% of the boxes can be underweight. So the company needs to set the machine to put out a little more cereal in each box. What mean setting do they need? Okay, so at first you might be like, gosh, I don't even know how to start this, but at least just start processing what is it you're looking for. You don't know mu, okay? So they're changing this, a little different. Put my normal model, mu's changing, but the standard deviation is still 0.2. The other piece of information I'm given is that the area that's underweight has to be less than what it was before, so I shifted it a little bit further to the left, and I'm going to label that area as the 4% or 0.04. Okay? So I kind of recognize, you know what, I got to work backwards. I got to find what this value is right here. And the way I'm going to do that is with inverse norm when I'm working backwards. Okay? But since I do not even know the mean, I'm going to have to go to the standard normal distribution. So this is my area. Mu would be 0 and sigma would be 1. So what this will produce would be my z-score when I use the standard normal. So that's going to give me, let's type that in, I get a z-score of -1.7507. I just take it out a few decimal points from my calculator, and that's my z. And I'm going to use I'm looking for the mean. So again, I'm kind of processing. I've got a z-score. I have a standard deviation. Well, why don't I go to the z-score formula, which states if I have an x minus the mean divided by the standard deviation, that gives me the z-score. So I know different parts of this. I think I can use some algebra to figure out my unknown. This was for a 16-ounce box, minus mu, and my sigma was 0.2. So I can use a little algebra here, multiply by 0.2, subtract 16, and then divide by a negative. That gives me a mu value of 16.35. So I know they need to set the machine to 16.35 ounces. Do a little better than I just did. Give me a sentence in context on the AP exam. Finally, the company president vetoes that plan, saying the company should give away less free cereal, not more. Forget what the lawyer says. Her goal is to set the machine no higher than 16.2 ounces and still only have 4% underweight boxes. Well, the only way to accomplish this is to reduce that standard deviation. So what standard deviation must the company achieve? Again, I might not be real clear here, but it says, okay, we're going to keep the mean at 16.2. 1, 2, 3, 1, 2, 3. And we're only giving away 4%, so somewhere over here. And that's going to be 0.04. Normal model, 16.2. Standard deviation, I'm clueless. But again, working backwards, I can at least, I'm given an area, so I can do inverse norm. I really don't need to do it again because it's the same area. I just found in the last problem that my z-score was negative 1.7507. Okay, so if I go straight to z-score formula and plug in x, 16 was my particular box, minus, president says keep that mean at 16.2, divided by the standard deviation. Well, now if I multiply both sides by the standard deviation, do a little algebra to solve this. 16 minus 16.2 is 0.2. Sigma, divide both sides by negative 1.7, and that should be a negative right there. If I divide both sides by this, that gives me a standard deviation of 0.114. So I know that the standard deviation must decrease to 0.114 ounces. This means the machine must be more consistent in its weights. Okay, so please reach out if you have any questions. Do lots of practice. The only way you're going to feel confident with this is to start doing problems that are asked in different ways.